Welcome to the Explainer. Today, we're journeying past the very limits of human sight to uncover the hidden anatomy of a genuinely fascinating target, Caldwell 48. If you've ever wondered what secrets are lurking just behind the glowing stars and cosmic dust, or how galaxies actually live and die, well, you're definitely in the right place.
So, let's just dive right into this by anchoring ourselves with a pretty staggering number. 67 million. That is the distance, in light years, to our subject today. It's located deep within the Cancer constellation, meaning the light we're seeing from this galaxy literally began its journey toward our telescopes 67 million years ago. It's a vast distance for sure, but as you'll see, the data we've managed to collect from it is incredibly intimate.
Section 1. Meet Caldwell 48, a historical profile.
Caldwell 48 actually has quite the pedigree. You might also know it by its alternative catalog name, NGC 2775. It was discovered way back on December 19, 1783, by the legendary astronomer William Herschel. So, this isn't exactly a new player on the cosmic stage. It's got a long-standing place in astronomical history and has been studied for centuries. But despite that long history, it's still held on to some major surprises.
Visually speaking, Caldwell 48 is what we call a flocculent spiral galaxy. Now, the word flocculent essentially just means fluffy. So instead of the classic, grand, sweeping spiral arms that we usually picture when we think of a galaxy, like our own Milky Way, right? A flocculent spiral has patchy, disconnected arms. It almost looks like tufts of cotton just spinning out there in deep space.
Section 2. The flocculent spiral ring.
Okay, to really help us visualize the physical significance of this galaxy's totally distinct structure, I want you to keep a certain metaphor in your head, the cosmic donut. I know, it sounds a little funny, but honestly, as we dig into the data, you'll see exactly why this pastry comparison is absolutely the best way to understand the true anatomy of Caldwell 48.
Section 3. The invisible hydrogen halo and radio astronomy data.
Now, we're shifting gears from what we can see with our eyes to what the Very Large Array, or VLA, tells us. What we're looking at here are channel maps breaking down neutral hydrogen emissions. Basically, each of these little squares is a different velocity channel. What this proves is that the cold gas in this galaxy isn't just some uniform, boring blob. It is highly localized and incredibly dynamic. You can literally see the gas appearing and shifting position depending entirely on the velocity we tune our instruments to. It's like a giant cosmic puzzle.
And boom, this brilliantly illustrates our cosmic donut. When researchers take all of those individual velocity channels and integrate them into one single map, this is what pops out. Look at that massive dark ring of neutral hydrogen gas perfectly tracing the galaxy's shape. But then, look right in the middle. There is a strangely empty center, a completely barren hole sitting right over the optical nucleus of the galaxy. The gas literally just stops.
But wait, it gets better, because the gas in that ring isn't just sitting idle. The velocity field of that hydrogen proves it is rotating smoothly around that empty center, reaching a maximum circular velocity of 300 kilometers per second. So it's a massive swirling ring of cold material just spinning away in the dark. Let's just pause for a second and contrast these two realities. In the traditional optical view, we see a bright, prominent central bulge absolutely filled with visible stars and dust. It looks super densely packed. But in the radio view, which measures the cold neutral hydrogen, we see a massive ring of gas with a completely empty center. The places where the galaxy shines the absolute brightest to our eyes are totally devoid of this atomic gas. No gas at all.
Which naturally brings us to a really crucial question. Is the galaxy's center truly empty? I mean, if there's no atomic neutral hydrogen in the center, could there be other materials hiding out there instead? For instance, what about molecular gas, which is the actual fuel needed to forge brand new stars?
Section 4. The carbon monoxide mystery.
So because molecular hydrogen is notoriously hard to detect directly, astronomers use carbon monoxide as a tracer for it. What we're seeing plotted here are the carbon monoxide emission profiles. Notice what happens right in the center, at the 00 mark. The signal is incredibly weak, almost nothing. But as you move out along the galaxy's major axis, to 30 and 60 arcseconds away from the center, the signal spikes dramatically.
This composite view really ties the whole shebang together beautifully. We've got the optical view with those carbon monoxide spectra overlaid right on top, And it completely confirms our suspicions. The molecular gas is also entirely trapped in that outer ring. This is a huge deal. It means that both atomic neutral hydrogen and the molecular star-forming materials are utterly absent from the core of Caldwell 48.
Section 5. A galaxy's hidden anatomy.
So the absolutely crucial takeaway here is this. Caldwell 48 has a massive amount of gas. We're talking 300 million solar masses of neutral hydrogen and a whopping 1 billion solar masses of molecular gas. But all of it, every bit of it, is confined to a massive outer ring that's 2.2 kiloparsecs wide. And because all of this material is trapped out in the ring, the nuclear core, the very heart of the galaxy, is completely starved of star-forming material.
There's this great quote straight from the source data that I just love. The minimum in the center of the ring coincides with the optical nucleus. It so perfectly summarizes the grand paradox of Caldwell 48. Right where the galaxy is brightest to our eyes, just brimming with older stars, it is actually physically barren of the gas needed to create anything new. It's basically a glowing ghost town sitting right in the middle of a bustling ring.
And that leaves us with a final provocative question to ponder today. With its nuclear core totally starved of gas, what is the ultimate fate of this cosmic donut? Without any fuel for new stars in its center, how is Caldwell 48 going to evolve over the next millions or even billions of years? It's a fascinating thought experiment, and it really shows just how dynamic our universe is and how much is hiding right in plain sight. Thanks so much for joining me on this explainer, and as always, keep looking up.